Let's dive into Kubernetes service discovery interactively, exploring how services within a cluster find and communicate with each other. Imagine Kubernetes as a constantly changing city, with services, buildings appearing, moving, or disappearing. Kubernetes uses two methods for this discovery: environment variables and DNS-based service discovery. Ready to explore? 1. Environment variables. The static map, think of environment variables as a map provided to each citizen pod when they're created. When a pod starts, Kubernetes injects a set of environment variables into it, listing the addresses, IP and port, of services within its area, namespace. How it works: the environment variables follow a simple pattern. Each service has variables like service name, service host, IP address, service name, service port, port number. This means every time a pod starts, it has a preset map showing where other services are. Strengths: environment variables provide instant access, so the pod knows exactly where to go right from the start. It's simple, like a static map you receive when you enter a new city. Limitations: this map is static. If buildings, services change locations, the environment variables don't update. So it works great for stable areas, but it isn't as flexible in a city that's always changing. This makes environment variables suitable for less dynamic applications. 2. DNS-based service discovery, the dynamic GPS. Now, let's look at DNS-based service discovery, Kubernetes' more flexible option. Imagine each service has its own address, DNS name, and Kubernetes core DNS acts like a constantly updated GPS. Whenever a service changes, like adding or removing pods, core DNS updates its map instantly. How it works: each service is assigned a DNS name, like servicename.namespace.svc.cluster.local. Pods can connect to services by this DNS name rather than a fixed IP. Dynamic updates. Here's where the magic happens. Core DNS automatically updates DNS records in real time. So if a service scales up or moves, the DNS address stays accurate, just like a GPS that always knows the latest routes. Strengths: DNS-based service discovery is highly adaptable. No matter how much the city cluster changes, core DNS keeps services discoverable by name, making this method perfect for high traffic and scalable applications. Which method is best? Both methods have unique advantages. Environment variables are like having a static map, reliable but limited if the city changes. DNS-based service discovery is like a dynamic GPS, always current and ideal for evolving environments. In Kubernetes, the combination of these two methods ensures that services can find and connect to each other seamlessly, whether in a stable or constantly changing setup. So the next time you wonder how Kubernetes keeps everything in sync, think of these two discovery methods as the city's GPS and map system, working together to guide services through a dynamic landscape.